right. So are there any questions about this particular slide? Just about the move instruction, its general syntax, and what it does. No questions? All right, cool. The next section talks about the three main categories of operands. Now these are three different operand categories. The first one is called immediate. Immediate means, it's basically a constant. It is a bit pattern that is embedded into the instruction itself in machine code. In other words, if you carefully analyze the machine code in binary, you will see an immediate operand embedded into it. It is a number, a value, a bit pattern that is inside the instruction itself. Okay? So it can only be used as a constant and also as a source. It can never be a destination because it is a part of the instruction. The value of an immediate operand cannot change in most situations unless you want to deal with self-modifying code. Okay? Now, self-modifying code simply means that the instructions of a program can modify its own instructions. It is a big no-no these days because we have the execution prohibit bit now in the processors, which basically says, unless an instruction is in the instruction space, you cannot execute instructions. Now, can anyone tell me why we have that, execution inhibit bit in modern processors? Malware, in particular, what type of approach to compromise a computer? Buffer overrun and stack overrun. Buffer overrun and stack overflow. Stack overflow and buffer overflow type of exploits. Okay? The execution prohibit bit basically stops all of those approaches code. There's just no way to deal with it. There are still ways to alter the path of execution to the point where it can break a program and gain access, unauthorized access, but it will take a lot more work to make that work because you can change the return instruction to return to a place where it's not supposed to go to, but it doesn't give you as much control as buffer overrun or stack overrun. Okay, so the bottom line is, in most modern architectures, you cannot modify instructions, and because an immediate operand is a part of an instruction, you cannot change that. It can only act as a source. It can never act as a destination. Immediate operand can only be used as a source operand, so we just talked about that. The access speed of an immediate operand is super fast. Okay, it's not just fast, it is super duper fast because it is a part of the instruction itself. There's no way, it doesn't have to go fetch or grab something. It is already there inside the instruction itself. Okay, so that's an immediate operand. The next one is called a register operand. A register operand is one that refers to the value of a register. Now we talked about the rationale of having registers, right? Because memory is slow. So we need registers to be right next to the ALU so that it can keep up with the calculation. So that's why we have registers. We only have so many registers, not really that many registers. The 386 has a small number of registers. I think it has 8 registers, of which we will only use a few of those 8 registers. We talked about why there are only few registers, but this is basically a recap of some of that stuff that we talked about. A modern processor uses general purpose registers, which means all registers can be used as a source or destination of operands in an instruction. This means that a switch has to be implemented in order to let an instruction select any of the registers of the general purpose registers. And this kind of switch is expensive because it can map anything, any register as the input, to one of the 2 sources of the ALU, and then use the same thing for the other one. So it's a cross switch, which takes up a lot of routing resources. The second thing is a register has to keep up with the speed of an ALU because that's really the whole purpose of having registers. An ALU uses combinatorial logic to implement operations like add, subtract, divide, and so on and so forth. And this is, is really fast. In order for registers to keep up with this speed, they have to be physically close to the ALU, And there's only so much real estate close to the ALU, and that's why you cannot have a lot of registers either. But there's another reason that I have not really outlined here. It has to do with compatibility with existing software. Okay. With the Intel architecture, since really early on, we only have 8 registers to specify with most instructions. Okay. So a lot of the opcode, the binary code of the instructions, only allocate 3 bits to specify the source register and 3 bits to specify the destination register. Okay, and changing the opcode is a big deal, depending on whether some software is written to be easily cross-compiled. So let's say Intel says, you know what, we understand that 8 registers is not really a good number. It is not sufficient to optimize programs. So we'll bump up the number of registers to 32. Now with 32 registers, how many bits do you need to select one of the 32? You need 5 bits, right? So since we only allocated 3 bits in existing opcode, those opcode will no longer be compatible with the new processor that is now running with 32 registers. In other words, it won't be backward compatible anymore. If you want to utilize the 32-bit register, the 32 registers. So that's a big thing because backward compatibility of hardware is important to certain software companies. Not all, just some. Why is that important? Binary backward compatibility.
Programs can run on replacement hardware if the old hardware does.
Exactly. So that you can potentially say, oh, this computer is running really slow. I want to get a new processor that is running that's going to be twice as fast. Like what I have at home right now is a Q6600 running at the stock 2.4 gigahertz. I know most of you guys will say, but you can run it at 3-point-something gigahertz. Yes, I know, but I don't want to push it. Okay. So let's say I want to improve the performance of my computer without pushing it and saving power at the same time. So I want to get a new motherboard with an i7 processor, quad core. Okay. So right out of the box, without any type of tricks, I can get twice the speed already. I'm running Linux that is compiled for the 32-bit architecture. Do you think I need to do anything special to make my operating system run again using the new motherboard? Assuming the chipset is already supported by the operating system and all that stuff. Nothing. Okay, I don't have to do a single thing. I just change the motherboard. Change everything that goes along with the motherboard change, like new memory modules and stuff like that. And plug in the hard drive. My computer would start up and run twice as fast with almost no necessary changes, except for the NIC. Because the NIC would have changed, and I have to do something about that too. Okay, but minimal configuration stuff, and I will have my system up and running again. If the new processor is no longer binary compatible with what I had before, what would I have to do in order to make it run again?
You'd have to change everything in your operating system. You'd have to get a compatible operating system.
I will need an operating system that will run on that particular architecture. Now, in the case of Debian, it wouldn't be too hard, okay? Because if you go to Debian.org, and go to, let me see where it will have, oh, I know what. We just have to go to Debian packages, look up, and we'll look for Linux image.
You missed the A. You misspelled the image.
I misspelled it. Okay, there we go. All right. So when you look up these images here, you can see that they are all Linux image 2.6 because this is the stable version of Debian. But that part is not important. We want to look at the suffix. It has one kernel that is optimized for the 486 architecture, which is kind of old, but it will run on all modern architecture. With most newer computers, if you run it in 686 mode, it will run faster. It has one for Itanium, which is not binary compatible. to the i386 architecture. It has PowerPC. It has PowerPC 64-bit. It has 3 S380. Does anyone know what that architecture is?
It's an IBM mainframe.
Yes, it is an IBM mainframe architecture, and Debian has a distribution for that as well. So as long as my new motherboard is one of the architectures that is still supported by Debian, to me it's not a big deal because I just have to reinstall all the packages, get the and most of the configuration I can keep the same. Okay, like my email server configuration, that has nothing to do with the architecture at all. What if you're using Microsoft Windows? How many architectures does it support? Well, not one. It has multiple. It has 32-bit, 64-bit.
It has
I don't think they
Itanium.
support Itanium anymore in Windows 8.
The server version does.
The server version still supports Itanium.
Yeah.
And then what else?
Xeon, but that's still off 686.
Yeah, that's a specialization of the x86
Yeah.
architecture. So not really a whole lot of architecture supported. Okay.
Does mobile run on ARM?
The mobile runs on ARM, but I think the mobile version of Windows 8 is not really that close to the desktop version. Because they have to, Microsoft Office for tablets, the mobile version is considerably different from the desktop version. Originally, they wanted the two to be identical, and then they found out that they could not fit everything into the tablet version. So the tablet version is actually different now, even though they wanted both to be the same. Okay, so that means if I change the number of registers from 8 to 32, with an architecture like with an operating system like this, it may not be a big deal because I just have to select a different the same distribution but a different kernel, and the executable from a different repository, and I'll be fine. But with Windows, it's not going to be very helpful because Windows is not available for the new architecture. I have to wait until Windows or Microsoft comes up with a Windows ported to the new architecture in order to utilize the 32 registers. Okay? And that's why we are still using 8 general purpose registers. It's because of binary backward compatibility. Yep.
Does this mean it's probably gonna be like an eon or so before that actually happens?
Sorry?
Does it mean it's gonna be like an eon or two before that actually happens?
It will never happen. It will never happen. The other thing, I think most of you probably know this already. The amount of silicon and real estate that we have to put into a modern, let's say, i7 processor is really quite a lot. If it's not for backward compatibility and the ability to execute i386 type instructions, the same type of resources can be used to improve performance significantly. In other words, we are wasting a lot of resources just for the purpose of backward compatibility. And that's a software issue. It's not a hardware issue. It's not an Intel issue. It's a Microsoft issue. Because if Microsoft designed their software to be easier to be ported to a different architecture, like Linux or most of the open source software, a different architecture means some minimal work in terms of the back end, some code to be written in assembly. But if the architecture or if the kernel is written in a way that is more portable, most of it written in C and make it portable, it really should not be that much of a deal to port it to a new architecture.